Dear students, today I am going to talk to you on value addition to fruits and vegetables through processing. Fruits, vegetables and their products have gained considerable importance by contributing significantly to the nutrition and economy of many countries in the world. Along with the economic development, there is a general trend world over towards the increased demand for fruits and vegetables as a major component of the diet. They not only contribute to the food value, but are vital sources of essential minerals, vitamins and dietary fiber. In addition to these constituents, they supply complex carbohydrates, protein and energy. Almost all the vegetables are excellent source of minerals and add bulk to the diet, thereby contributing strongly to the good health. Fruits and vegetables being highly seasonal and perishable commodities, it has been an endeavor world over to evolve methods to prevent losses of these commodities between harvesting and consumption. The losses are estimated to be of the order of 25 to 30% in many tropical and subtropical countries. Processing these crops into shelf-stable and value-added products is one of the most common methods to minimize the losses. Processing of fruits and vegetables, besides curtailing post-harvest losses, can add value, extend season, ensure better economic utilization of fruits and vegetables, and impart convenience. With their exotic flavor and variety, there is an increasing demand for tropical and subtropical fruits and vegetables and their products. Depending on the method of processing, the nutrient content of the foods are lost to a varying extent. One of the major objectives of the technological development in food processing is minimizing these losses. Hence, processing conditions should be such that processed products will have minimum loss of nutrients present in the raw material. For continued viability of food processing industry, it is necessary to keep pace with the changing the technological development to provide processed products having better quality and variety. This episode deals with production of fruits and vegetables, post-harvest losses, primary processing of fruits and vegetables, processing technologies and processed products. Production of fruits and vegetables. The diverse agroclimatic conditions such as tropical, subtropical, temperate, arid and semi-arid prevalent are conducive to the growth of wide varieties of fruits and vegetables in many countries. India has emerged as a major player among the fruit and vegetable producing countries, occupying a second position with the current production of over 150 million metric tons of fruits and vegetables, of which India produces 50 million metric tons of fruits and 98 million metric tons of vegetables. Processing of fruits and vegetables also enables conservation of crops besides importing convenience and value addition. The major fruits grown are mango, banana, citrus, pineapple, apple, grapes, sapota, papaya and lychee. The other fruits, sometimes referred to as minor fruits like avla, passion fruit, annona, mangosteen, avocado, bale, olive, jackfruit, jamun, etc. have potential for their commercial exploitation. Similarly, a large variety of vegetables are grown in the country. The major among them are brinjal, cabbage, cauliflower, okra, onion, peas, potato and tomato. The major fruits and vegetables grown are banana, occupying number 1 position in the country, followed by mango, and citrus stands third. Whereas in case of vegetables, potato stands first in the production of vegetables, followed by brinjal and tomato. Besides major tropical and subtropical fruits, the second category of fruits classified as minor or underutilized constitutes a very large number of fruits. Important fruits in this category are listed below in the table 3. The fruits in this category include cashew apple, custard apple, jackfruit, karonda, kokum, lychee, pomegranate, sapota and watermelon. Some of these crops are cultivated and also grow widely in many countries, though substantial quantities of these fruits is produced. Reliable production data for these fruits are not available. Many are known for their therapeutic, medicinal and nutritional value and have very good demand. Except for lychee, which is a commercial process, the other fruits are rarely processed. In recent years, considerable research and development work has been carried out to develop products from these fruits. The technologies developed, if put to use, could enable better economic utilization of these crops, some of which have potential for extensive cultivation in arid and semi-arid regions. Post-harvest losses. Post-harvest losses in fruits and vegetables in most of the tropical developing countries is very high due to adverse climatic conditions, inadequate infrastructure facilities and inherent physiological nature of the crops. Being highly perishable and seasonal in nature, unless suitable measures are taken, fruits and vegetables deteriorate in quality and value and ultimately lead to losses. Therefore, the conservation measures should start from the pre-harvest orchard management to control microbial and insect infestation, harvesting at optimum stage of maturity, adopting appropriate methods and careful handling of the commodities throughout the handling system. The post-harvest losses of fruits and vegetables are presented in the table. The losses in case of papaya, the losses are to the tune of 30 to 50% and least in case of apple to the tune of 10 to 18%. Whereas in case of vegetables, in post-harvest losses in carrot are in the range of 4 to 8%, whereas maximum losses were observed in case of cauliflower, which accounts for 41 to 47% of losses. Value addition by processing. Fruits and vegetables are processed into large number of value-added products in the country. There are about 4,930 FPO license units in the country with a total installed capacity of 2.04 million tons. The production of processed fruits and vegetable products has shown a steady increase over the years and presently it is around 0.96 million tons. Primary processing operations. For better sanitation, storage stability and in order to improve the nutritional qualities of processed fruits and vegetables undergo certain common unit operations such as selection, handling, sorting, washing, peeling and slicing, which are briefly discussed below. Selection. The quality of the processed products depends largely on the quantity of the incoming fruits. Therefore, it is important that fruits and vegetables of right quality suitable for different processed products are produced. This has led to the captive production of crops by processing units or enter into contact farming. An understanding of the harvest principle can help the decision makers to plan the operations that results in the highest fruit quality possible within the specified economic constraints. Harvesting the fruits at its optimum stage of maturity, optimum color, size, etc. is carried out mechanically or by manual harvesting. Most mechanized harvest techniques rely on mass removal of fruits, which usually results in more damage than is commonly found with the manually harvested fruits. Handling. An understanding of the mechanical properties of fruits enables the design of conveyors, lowrators, containers and other equipments that minimize bruising. Bulk handling methods are rapidly being adopted to reduce cost and to enable increased mechanical harvesting rates. Impact during handling of fruits are one of the most common causes of bruising and results in large economic losses. Impact occurs when the fruit is harvested either manually or mechanically, during movements to containers, while in transit, upon container dumping, and during handling at a processing plant. Reduction in bruising would increase promising yield and permit longer storage period for raw material. Sorting. Sorting is performed to segregate material into lots based on fruit characteristics such as maturity, color, weight, size, defects and firmness. Sorting of fruits enhances the value of the crops by providing a more uniform product. Sorting methods can be categorized as manual, mechanical or electronic. Washing, peeling and slicing. Fruits and vegetables are washed to remove dirt, dust, insect, mold, spores, plant parts and filth that may affect the color, aroma or flavor of the fruit. To be most effective and economical, washing with water must be accompanied by bruising, rubbing and forcing the water against the fruit and into crevices. Detergents are frequently used in the washed or rinsed water. Washing with water is always supplemented with the air currents to remove light material and perforated or rod skins to remove small and heavy materials. Peeling is one of the most important preparative steps in processing of some fruits and vegetables meant for canning, freezing and dehydration. The selection of proper peeling method is of the importance as quality of the finished products depends to a large extent upon the method used. Various peeling methods such as hand peeling, peeling by heat, live peeling, acid peeling, dry caustic peeling, calcium chloride peeling and mechanical peeling are followed. Processing technologies. A large number of traditional technologies have been in vogue since time immemorial for fruits and vegetable preservation. They include pickling, drying, fermentation, preservation in high sugar. Many of these methods have evolved into modern technologies. Simultaneously, newer technologies like thermal processing, particularly aseptic processing, freezing, vacuum concentration, membrane processing, etc., have also emerged. A few of the widely practiced technologies are enumerated below. Thermal processing. Processing of fruits and vegetable products in open-top sanitary cans is widely practiced. Many vegetables like potato, okra, bitter gourd, beans, cabbage, tinda, parval, and fruit products like mango and other fruit pulps, pineapple slices, lychee, guava, etc. are canned. For thermal processing, tin plate cans are predominant packaging material, but glass bottles are also used to limited extent. Possibilities of using retortable pouches, aluminum cans, tin-free steel plates, etc. have been established, and these are likely to be used widely in the near future. Further improvements in the quality of thermally processed foods have been achieved by high temperature short time processing, as in case of aseptic bulk and unit packaging. Juice extraction and clarification. The consumption of fruit juices has been increasing world over because of their richness in essential minerals, vitamins and other nutritive factors. Besides, they are delicious and have universal appeal. In the juice recovery process, apart from thermal extractives, heat extraction and enzymatic liquefaction, mainly mechanical pressing system such as hydraulic press, pneumatic fruit juice press, continuous plate press, continuous screw type press, horizontal basket press, screening centrifuges are employed. Recently, microbiologically produced polyphenol oxidases and adsorber resins have also not only eliminate existence of browning, but also link colorless oxidizable polyphenols and also minimize browning tendency. Recent developments have shown that adsorber resin in combination with ultrafiltration can be used effectively for debittering of citrus juices and its byproducts. Fruit juices, pulps and concentrates. Fruit juices, pulps and their concentrates occupy 27% of the total processed products. For juice extraction, pulpers and presses are widely used. Juice clarification is usually achieved by plate and frame of leaf filters, but micro and ultrafiltration are also being introduced for the purpose. Ultrafiltration adds value to the product by imparting better stability against sedimentation, and the process is cleaner. Clarified fruit pulp juices enable concentration to high solid concentrates. The steep rise in cost of packaging and also to have convenience. Concentration of fruit juices has become a major unit operation. Concentration is achieved mainly in vacuum evaporators, either in single or multiple stages. Different types of evaporators like calandria, plate, centrifugal, agitated film and scrape surface are used depending on the rheological as well as thermal sensitivity of the product. Aroma loss, which is the major drawback in the fruit juice concentration, has been overcome by aroma recovery and restoration of the lost aroma. Evaporation, being energy intensive and liable for causing thermal damage to certain juices, membrane concentration process has been established. Drying and dehydration. Dried products are shelf stable and require less expensive packaging. Drying of some fruits and vegetables using sunlight is a traditional method. Even though some drying is still being used, more widely practiced method is by using different types of dryers where dehydration parameters can be more or less precisely controlled. Batch dryers like the cabinet dryers are the common dryers for many products. Even though continuous belt dryers having better humidity control yields product having better reconstitution and sensory qualities, still they deviate significantly from the fresh material. Therefore, for more expensive and sensitive products like fruit cubes, freeze drying is applied. Freezing. Freezing has long been established as an excellent method for obtaining high quality food products. Generally, it preserves the taste, texture and nutritional value of the food rather better than any other preservation method. As a result, ever increasing quantities of fruit are being frozen throughout the world. Freezing preservation of fruit depends on inhibition of post-harvest physiological changes along with inhibition of microbial action at low temperature. For prolonged storage, the temperature must be well below the freezing point of water. Chilled food markets have experienced enormous recent growth and improvements in the nutritional and sensory qualities of novel heat processed foods which have comparable shelf life to the frozen counterparts have resulted in these preservation processes taking a considerable market share. In order to obtain high quality frozen foods, high quality raw material are necessary and processing, distribution and storage must be carefully controlled. Frozen fruit chunks of mango, banana, guava and papaya and vegetables like peas, cauliflower, carrot, tomato, etc. are being frozen and marketed. An emerging technology for monitoring the temperature regime experienced by frozen foods during distribution and storage are temperature and time temperature indicators. These devices may be either threshold indicators which show that the product has been held above a special abuse temperature or integrating devices that can reflect time and temperature dependent safety and quality changes. A cost effective alternative to a 100% cryogenic IQF freezer is the use of combination freezers which use a combination of cryogenic and mechanical technique. The principle of operation of combination system is to use a cryogenic freezing unit for initial freezing of the outer surface of the product, followed immediately by mechanical freezing to reduce the temperature of the bulk of the product to the desired frozen temperature. Combination freezing system has also been developed for freezing of liquid, semi-liquid foods such as fruit and vegetable puree. A combination treatment involving freezing in conjunction with irradiation has recently been proposed as a means of reducing spoilage prior or following processing. In order to preserve the high quality of frozen foods, rapid freezing techniques such as fluidized bed and cryogenics are becoming more widespread. Frozen products are near natural products. Though not widely produced in the country, their demand both in the domestic as well as export market is increasing. Pickling. Pickles are the traditional products in the country. High salt cured unfermented pickles and vinegar pickles. Modernization of pickle industry by improving the various unit operations has enabled better and consistent quality and value. In order to reduce packaging cost and impart convenience, dehydrated pickles based on mango, lime and several vegetables have been developed and commercially produced. Even though fermented pickles are rare in the domestic market, high value fermented gherkins worth more than 200 million are exported from the country. Osmotic dehydration. Partial dewatering and direct formulation of fruit and vegetable pieces can be obtained by immersing in a concentrated solution of salt or sugar. This process is known as osmotic dehydration or dewatering and impregnation smoking process. This process can be used as a pre-treatment before any complementary processing steps such as drying, freezing, pasteurizing, canning and or addition of preservative. Fresh fruit pieces are first soaked in sucrose syrup, possibly blended with inverse sugar, in a batch system at a normal pressure and at a temperature in the range of 30 to 80 degrees Celsius. Products are then air dried, which leads to final water content in the range of 15 to 20%, weight by weight basis. Osmo-dried fruits are mainly prepared from pineapple, papaya, mango, jackfruit, banana, ginger, etc. High sugar products. High sugar products like preserves and candies are traditional products in the country. Raw papaya candy like Tutti Frutti is an important commercial product finding extensive use in bakery products. Jams, jellies and marmalade are also produced to the tune of 10% of the total fruit and vegetable products. Chemically preserved products. The only two chemical preservatives permitted under Fruit Product Order 1955 in the country are sulfur dioxide and its sodium and potassium salt and benzoic acid and its sodium salt. Processed products. A number of processed fruits and vegetable products are produced by the Indian food industry, the percent breakup of which is presented in the table below. The fruits and vegetables occupy about 27% of the total fruit and vegetable products processed by the Indian industry, followed by RTS beverages, which occupies or the market share of which is 13%. Pickles occupy about 12% of the market share, followed by jams and jellies, which occupies about 10% of the market share. Syrups occupy 8%, squashes occupy 4%, tomato products occupy 4%, canned vegetables occupy 4%, and other commodities which have not been mentioned occupies about 18% of the total fruits and vegetable products processed in the country. For the preservation and processing of fruits and vegetables, a number of methods are in vogue, and these methods are classified into three different categories like physical methods, chemical methods and fermentation methods. Under physical methods, we have removal of heat either by refrigeration or by freezing. By these two techniques, it has been possible to extend the shelf life of fruits and vegetables. The next is the addition of heat, that is by thermal processing. For example, in case of canning, bottling and aseptic packaging, wherein the product packed in can or bottles or aseptically packed are again subjected to a thermal processing step. Removal of water either by drying or dehydration, or sometimes a concentration step wherein the water is removed from the food material to the extent of 50 to 60%. Then we have irradiation either by ultraviolet radiation or by ionizing radiation, as it is followed widely in case of sprout innovation of potato and onion. Chemical methods of preservation includes addition of acids like preservation of pickles or preservation of chutneys by adding vinegar or lactic acid. Other technique is the preservation by salt brining, as it takes place in case of pickle preparation. And the third category is the sugar preservation of fruits and vegetables by sugar, as in case of preserves, candies, jams and jellies. Chemical preservation includes the use of sulfur dioxide in the form of sodium or potassium salt and benzoic acid and their salt. The third method of food preservation is fermentation, that is either by alcoholic fermentation or by lactic fermentation or by acidic fermentation, as in case in the preparation of wines, apple cider, vinegar, sauerkrauts, etc. Combination of one or more technologies always results in the product with high acceptability both in domestic and international market. Thank you.